But there's even more to life than water and energy. So let's go through the whole list. If we wanted to say this place is habitable, I think you got to have 4 things. Carbon. Okay, that's easy on Mars, CO2. Liquid water, water activity in ice at -10, check. Energy, check. Well, there's one more that we really got to have if we honestly want to say we found a habitable site, and that is nitrogen, a major macronutrient, nitrogen. Right? We don't know anything about nitrogen on Mars, unfortunately. The instruments that flew on Viking, Pathfinder, and the 2 rovers were all X-ray fluorescence instruments. They work by looking at the X-ray fluorescence for molecules excited by other X-rays. They could not detect any element with atomic number less than 11. Over here, that happens to be a periodic table. And you can see that nitrogen has atomic number 7, which is less than 11. In fact, nitrogen, oxygen, carbon all have atomic numbers less than 11. The X-ray fluorescence instrument is not a very good instrument for astrobiology-interested molecules, but so it goes. Phoenix was going to be the first mission that carried a sensor capable of detecting nitrogen.
And then you perchlorated it.
And it got perchlorated. Unfortunately, this instrument was 1,000 times more sensitive to perchlorate than it is to nitrate. But we didn't worry about that because we didn't think there was any perchlorate on Mars. So we went there to measure nitrate, and instead it measured perchlorate, which was cool, but it couldn't see the nitrate because it's 1,000 times more sensitive to perchlorate. So we were blind to nitrate. So the nitrate remains a mystery. So
the Curiosity lander that's going up in a couple of years, is it looking for nitrates?
the MSL? MSL.
It just got nicknamed Curiosity.
Oh, did it?
Yeah.
Oh, that's curious. It is not capable of detecting nitrates.
Why not?
Because to detect nitrates the way Phoenix did, you need a wet chemistry system. It doesn't have a wet chemistry system. It doesn't have, I don't even think it has an X-ray fluorescence. It has basically 2 instruments, a X-ray diffraction instrument for doing mineralogy, and it has a organic detector, a GCMS, for doing organics.
Is it going to run into the same problem?
Yeah. It's going to run into the same problem with the perchlorate. We're in denial, by the way, officially. I'm a co-I on that instrument, and we are officially in denial. Fortunately, that instrument has 10 little jars of liquid. It can also do liquid extraction as well as pyrolysis, so it doesn't have to cook the sample for those 10 cases. And so we might be able to work around that. But we are slowly, it's too late to change the instrument. MSL is already over budget, late. It's too late to change anything. We just got to figure out what to do about it. And the answer, the hope is in those 10 liquid cells. Question there?
How can you be sure it was water?
What was water?
The ice.
How are we sure the ice was water? Well, we did see it in the GCMS, in the TIGA. We did see a water spike. And the real argument that it was water, though, was that it evaporated when we watched it.
But other ice formed chemicals would evaporate too, right?
Yeah, CO2 would evaporate, but it's much too warm to be CO2. It evaporates at the right temperature and the right rate for water. If this was CO2, it should have just gone, should have just literally fizzed. That's really the only other possible thing that could evaporate. So we're pretty sure it's water ice. Let's go back to energy, habitable zone. Next, I want to now talk about Mars, show you Mars Science Laboratory in case you haven't seen it. They've got a full-scale model on display in their tent downtown. Go look at it. Right in front of the value mark. Right to the side of the value mark, there's a big white tent. There's a sign on it that says not open, just walk in anyway. That's what I did this morning. Why is it not open? Go in, it's empty. There's a big, full-scale model of this thing. You get a sense of how big this sucker is. It's huge. Again, these are almost normal-sized people. Where is it going to go? It's going to go to equatorial sites. Holden, Eberswalde, Warth, or Gale. One of these sites. And what these sites are chosen, first they have to be near the equator. because the bearings on this spacecraft can't take the cold. Figure that out. But these sites are all sites which have clay, which dates back to an early wet period in Mars history. So they want to look in that clay for organics and look at its mineralogy.
You said that you're expecting to run into the same perchlorate issue. How do you know that there will be perchlorate in the equatorial regions as well as the polar?
That is a very, very important question. And it's a very important question. And I was just on a telecom earlier today, which may be the answer to it. Remember the Viking missions? They heated up samples in a GCMS and then looked at the gases. And they reported no organics detected as parts per billion level. And that's been the dogma about Mars ever since, no organics. Viking didn't see organics. But now, if there was perchlorate in the soil, you wouldn't expect to see organics because the perchlorate should react with the organics and destroy them. But they don't exactly destroy them. We're doing some experiments, and the guy that's doing the experiments is a really good analytical chemist in Mexico City. And I was literally on Skype calling him about an hour ago, saying, "Hey, Raphael, what's news?" And he said, "Well, when you put perchlorate in the Atacama Desert soil, which is sort of our Mars-like soil, and heat it up the way Viking did, it destroys most of the organics, but you see methanochloride come out. Methanochloride. So the chlorine reacts, gloms onto a methane, and comes out as a gas. Methanochloride. Well, the curious thing is that Viking saw methanochloride come out. At the time, they said, oh, this must have been used as a cleaner, because methanochlorines are used to clean things. It's one of those things you use to degrease components. So they didn't know what for, so they said this must just be a cleaning compound. So it may be that if we go back and relook at the Viking results, thinking with perchlorate, we find not only evidence of perchlorate, but evidence of organics, and they reacted together. So I'm betting that there's perchlorates everywhere. Plus, the way we expect Mars to be like, perchlorate should be present everywhere. So it's a interesting situation. You've probably seen this image of the lander. I just want to show it for those in case some of you haven't. This is really quite remarkable. MSL looks just like any other mission as it comes in. Aeroshell, parachute, heat shield, parachute, jettison the heat shield, here comes the parachute, pops out, on its way down, just like Phoenix, pictures taken in MRO. Here's where it starts to look different. The spacecraft is hanging from the bottom. The wheels deploy while it's still flying. Then it pops the back shield, and this thing drops out and hovers like a helicopter. Jets are flying, it doesn't land. It's going to hover above the ground.
Repel down and then break.
And it's going
the
to lower
chain of
down.
explosive bolts, like I
Yeah.
wrote in my newsletter.
Isn't that something? When I saw this, I thought they were joking. You see these joke videos where they've got the rover spinning around the rock and the beard on the mark. Oh, I thought it was one of those. Lowers down, and then it goes off and crashes.
And you hope it doesn't get the.
Yeah, you hope it doesn't crash straight down. That's probably pretty easy. Then it deploys and goes. And go look at how big that thing is. Imagine hanging on 4 cables. But back